Hello, this is Geoffroy, and I'm currently attending the Berkeley X class, Engineering Software as a Service. And last week in the homework one, part three, we had a really interesting exercise called rock, paper, scissors. And um, I work with my partner in a pair programming session, and we had a slightly different approach to how to solve that problem. So, um, we both coded it in a different way, and both work. So this is what I'd like to take a look at in this session, and obviously focusing more on the object-oriented approach, and what really motivated me to do this short segment on that topic is that I saw on Stack Exchange a question that was directly around, and I'm going to quote it here, object-oriented design patterns and problem-solving techniques. And the individual who posted that question was looking for specific pointers and resources that could help him in that regard. So since I had solved the rock paper scissors exercise using an object-oriented approach, I thought, well, why not do a little video on it where I would share what I had done, and especially since it's a pretty short exercise, we don't have to get into a lot of considerations to cover the problem at hand. But regardless, it's still enough to highlight some of the things that make the approach definitely different than a pure algorithmic approach. So to begin, what I'm going to do is I'm going to show the code that we actually wrote together with my partner. And as you probably remember, we had a class, rock paper scissors, and we were asked to write a method, a class method, a self winner, that takes two parameters, player one and player two, where each one of those is actually a little array with the name of the player and the strategy that they're going to pick to play against each other. And so besides that exception that we raise in case in case the strategy is not specifically in that array of three different options, then what we do is we go through each one of the different cases that we might encounter, and that's going to determine which player is actually the winner of the game. So that's basically the logic we came up with. Obviously probably one of many different ways to write the code that solves those requirements. But as I said, this is probably more the algorithmic approach, where the focus is directly on writing a sequence of instructions to solve the problem at hand. And it worked. We have we have a class, rock paper scissors, that defines the boundaries of our system, and we have this method that defines an interface, how we're going to communicate with this class. And that works just fine. So the tests passed, and and that's it. We're done. And it's true that for the class, it works, and we can move on. In the real world, it's obviously a little different because the code is going to be around for a while, and it's not unlikely that things are going to change. New requirements are going to come in, so the code has to evolve. And tomorrow we might have more strategies. We might have different rules that apply. We might have different types of players, and so on and so forth. So as things get more complex, then we're going to have to change the code. And obviously, the question is, how can we anticipate the changes and code for them? It wouldn't be nice to have some kind of crystal ball, and so we can look into it, and then we would know, what changes are going to come along in the next, year, 2 years, 3 years, and then we design and we plan accordingly. But we can't. So, yeah, OO is really not a crystal ball, but by applying good OO principles, we can build applications that will be able to evolve more gracefully. And on top of that, with a good test harness, a good suite of tests, then we might even be able to do some, drastic, pretty drastic refactorings down the road, and still feel confident that we're not going to end up with a disaster in production. So, okay. So, question is, let's start with this. Where does my code go? In a file, of course, but then but I also have something called a class. So what does a class do? What code do I put in those classes? So I have things to do, responsibilities, right? So where do I put them? And this is where objects really come in. There should be a cohesive bundle of data and methods. So a good place to start is with the domain of my users, the domain of the problem at hand. And before I throw in some of the things I usually get started with, then I like to quote Hunt and Thomas, and actually it's a quote that comes from the course, that's mentioned in the course. Every piece of knowledge must have a single, unambiguous, authoritative representation within a system. So obviously we deal with more than just instructions in an application. We deal with that knowledge that's a representation of something that's done in the real world, and we're trying to automate in some way. So how we organize all of that knowledge is going to have a huge impact on the quality of our design. So how do I get started? Well, there are several different approaches, and some more formal than others. And here I'm going to show you what I did. So I'll share very candidly, what I did, and here we go. So just some scribbles on a notepad. And what can we see here? And obviously it wasn't recorded as I was scribbling down, so it's, you get to see everything at once, which might be obviously a lot of information. But I try to guide and show how I think about the problem. So the first thing is there's the kind of the system I'm dealing with. So in this case, we have a class, the rock paper scissors class, and we're being told that it's going to expose this winner method, and that's how the work is going to get done with two pieces of information, right? So the player data that's going to be passed around, and right there, here we go. I've got a player, and then the player has a name, but it also has a strategy, right? And the strategy has a name itself, obviously. So right there, I can see that I'm going to be dealing with two concepts that are probably of interest here, right? So player one and player two are going to play against each other. So before I go any deeper, one thing that experience has shown me is that outside my what I would consider my system, my world, I have ugly barbarians with data structures and whatever. So that's what I'm being passed from the outside, and that's okay. Now, the first thing I want to do is transform that into objects. And once I have objects, then I can ask them to do stuff. So for instance, a player is going to have a name, maybe other attributes. I know that a player is going to play against another player, so one is going to be the winner and the other one won't be the winner, and things of that nature. So there might be other attributes. I know when I read the requirements that when they get to play against each other, if they both have the same strategy, then the one who wins is the one who's first, so to speak. So those other pieces of information might lead to some additional attributes. But for now, I know that I have a player with a name. The player has a strategy. Strategy seems to be something fairly complex. So maybe I'll want to make it its own object. But at this stage, it's all about exploring. So I haven't necessarily set myself or committed myself to any specific set of classes yet, but I'm exploring, and so I'm trying. I'm playing with ideas and seeing how they unfold. So at this point, maybe a few comments. One is I could definitely try to formalize things a little bit more. Maybe that's something I'll say for later on, because as I said, I'm really exploring. I'm maybe more in the this upfront creative thinking part of the process. So I don't want to necessarily slow myself down, trying to too quickly use any kind of notation and try to formalize things too much. But that's the thought. Another point is, okay, so I've got data coming in. I'm going to create my objects, my player objects, and then what do I do? Well, basically, I'm going to tell one player, hey, you're playing against the other player, and that's pretty much it. And next step would be to think about, okay, what do I need to do when I'm going to do this play against action? And you can see here that I played with several different names, and it's not unusual to go through that process of looking at different options to see which one communicates best. And I guess this is something that I got from Ken Beck a long time ago, and he said, well, there's nothing like an intention revealing name, and that can apply to obviously anything from classes to methods, variables, you name it, right? So um, it's always worth spending a little of time exploring which name is going to express best what you're trying to accomplish. But and it's never too late to come back and change it, and that's where a good development environment should allow you to easily do that refactoring when you need to do it. But so a player plays against another player, and really what is it all about? And the one thing that I thought of was, well, especially since in the requirements, the way that the strategies are presented and how they compare to each other was presented was something like this. Then I thought, well, wouldn't it be nice to be able to just say, hey, if excuse me, if my strategy is greater than your strategy, then I'm the winner. And of course, if yours is greater than mine, then okay, you're the winner. But I thought, well, it would be really nice to actually be able to express things just like this and compare two strategies, two strategy objects, and wow. So being new to Ruby, I thought, well, what is it going to take? And we had seen in a previous section that you could include comparable, and if you implemented in the class that includes comparable the spaceship navigator, then you get all the other comparison operators for free, so to speak. So that's one thing that I looked into when I started thinking about using this approach. And you can see down here the little scribble that shows that thoughts of what would happen in that play against methods in class player, of course. So I would have some code like this, self.strategy greater than opponent.strategy, and that would make me the winner. So I thought, hey, if I can indeed implement that spaceship navigator, spaceship operator, sorry, then maybe this is something that could work. So I took a look at all the different combinations that you have to deal with, and from there I started thinking about the code I needed to write to implement the operator, and that operator returns 1, 0, or -1. So it was really a matter of figuring out based on the table what value was going to be returned. So I can see that I've got 9 different cases, and I'm going to be returning 0, 1, or -1 for each one of those cases. So at that point, that's something I thought, well, I need to test that in code to make sure that in Ruby I can actually write that and it's going to work, and if it does, then I can move forward with something else. If it doesn't, then I'm going to have to reevaluate my strategy, so to speak. So let's take a quick look at the codes, and of course it's going to be all nice and pretty, but it obviously didn't start that way. But once again, I guess I could go back in history, because with Cloud9 you have this option where you can show the file history, and yeah, you can go back in time, but I'll keep it simple here. So let's scroll down and take a look at the strategy class. So it includes comparable, and as I worked on the class, I added a few things, but really the core that I started testing that we just discussed is this piece here. So here's the spaceship operator, and as I said, basically the different cases that I dealt with. And yeah, and I'm just thinking, ooh, okay, I used other here. I could have used opponents, but um, that's no, sorry. Let me take that back. That's the other strategy. So getting the strategy and the player mix up here. So let's backtrack and erase that. And so I have both strategy objects that I'm dealing with, and I'm comparing the names and then returning the values. And as you can see here, I've got all 9 of them, and that worked. And so I had some tests to make sure that things were working as expected. But that done, then this solved that piece. And just as a quick comment, I added a 2 string methods here, and in the initialize, it takes care of raising the exception if the strategy name that is being passed is not included in the set of strategies that we're dealing with. One thing I've tried to do is make sure that the information is captured in one place. So here we have the mapping between the code and the actual strategy name. I'm using symbols instead of strings. That's a minor thing, just kind of playing with the features of the language. So excuse me, going back to my scribble, then at this point I know that I can actually encapsulate all the information that's related to the strategy in a strategy class, and then I can compare very easily two strategies, which at that point gives me the confidence that, okay, I'll be able to write code like this, which if I backtrack once more, tells me that, oh, okay, so I'll be able to actually once I have both players, I'll be able to say, hey, player 1, you've got to play against player 2, and from there things will happen. So let's go and take a look at the code. We have we know that we need to have this RPS class. In that class, we'll have this method. This method will give us the data of the first player, the data of the second player, and from there we can go and create 2 instances of player, have them play against each other, and then once they're done, we can say, okay, who's the player, and display or return, actually just return the data of the player who won. So let's take a look at that code here. So once again, I'm looking at my class rock paper scissors and the methods winner. So it's actually a class method at that point, and is what I just set. I'm creating a new instance of player with the data for the first player, and then a new instance of a second player with the data that's being passed, the name, the strategy, and whether the player is first or not the first, which is important since we know that in the case they both have the same strategy, that's how we'll be able to differentiate who actually wins. And then here we go. I tell player one, you play against player two, and once they're done, I'll be able to check on who's the winner. In this case, I can basically just say, hey, player one, are you the winner? If it's yes, then I'm returning the data for that player one. If it's no, then I'm returning the data for the second player, and basically we're done. So let's take a look at the class player. So we have a number of attributes, and we of course have a constructor. And real simple, the name. The strategy. The strategy is actually that little letter that I'm given, and guess what? Instead of just keeping it as this simple type attribute, again, as we discussed earlier on, I'm going to create an object of type strategy, and I'm passing the data that I'm being passed regarding that strategy. In this case, it's just that letter, but I'm still encapsulating it in a class, in an object. So that's my strategy attribute. And then, as we discussed, I've got first and whether or not I'm the winner. Which at the beginning, it's fair to say that I don't know yet. So I'll say I'm not. I'm not. I'm not. So that takes care of initializing new players. Now the method we discussed was play against. So I'm playing against an opponent. So what do I need to do? And I'll jump to the code down here. And that's really what I focused on initially. And you remember on my scribble, you saw that that part. It's not unusual that as you work through the problem at hand, you deal with one specific issue or sub problem, and once you're done with that part, then you usually allows you to kind of step back and look at the other pieces. So here we've got that's really simple code where each player asks its strategy, compares the strategy, and that determines who's the winner. Real simple. And in the case they have the same, then obviously the one who's first is the winner, and that's it. So why put that code in another method? Well, because there's still a possibility that we would be in a situation where, for any reason, both players would be first, for instance, which you don't know how that could happen, but you can't rule it out. And what I thought was, well, okay, I've got two players, and here's a little truth table that captures what happens with their first attributes. So if Bob is first, if Bob is not first, if Alex is first, and if Alex is not first. So I've got that little truth table, and what that tells you is that there's really only two situations that should be allowed. Otherwise, there's a problem. Maybe somebody cheating. So it actually kind of works out, pretty well, because those two situations actually match. So whether it's okay or whether it's not okay, well, that actually corresponds to the XOR operator, the XOR Boolean operator. But going back to the code here, in the play against methods, I realized that, hey, you know what? I really don't want to just show some kind of, Boolean operator, especially like XOR. Again, it's all about conveying the intent. And, a XOR operator might not really convey that well what I'm trying to accomplish. So here, I've encapsulated that behavior, a really simple behavior, but I've encapsulated it in a method is rank different. And, that's going to return true or false. And actually, I'm thinking, ooh, in Ruby, maybe I should have question mark here. But anyway, so that's a different story. So this is exactly what I do in this method. Return, and I'm comparing. I'm combining the two first attributes with that XOR operator. And you can see here that I'm writing a method that has just one line, and I could have spent myself so I'm writing 1, 2, 3, 4 lines of code where I could really just have this piece. And again, this is something that I've seen a lot in object-oriented programs, where it's not necessarily about how many lines of code you write, it's how expressive the code you write is. And I reveal my intent, and then I provide the implementation. So this is yet another example at a very small level, very granular level of I try to express the what before I show the how, and I think that by combining this simple principle at all levels of an application, you can have code that's a lot easier to grasp and understand. So each time you have a method that does a little bit of work, and then that delegates the rest to oneself or another object, and that way by breaking down things in little pieces with expressive names, then you end up with code that's going to be a lot easier to maintain over time. Well, at least that's the goal. So that being said, it takes care of this piece, and I could have shown the codes we just looked at down here directly underneath the if condition. But what? It's really all about, well, I'm now in the situation where players are actually playing fair, so let's encapsulate that code in a method with hopefully an intention revealing name. And finally, I have the else that says, hey, what? There's something smelly going on. So here you go, raising an error with cheating going on, right? And basically that's it. So when you think about it again, and if you were to compare, this code to the previous code, obviously we have more lines of codes. That's probably even still more characters overall. But now it's structured in a way that's going to give us, more flexibility to evolve the code over time. And and even though it's not necessarily obvious from the get-go, if we had more iterations where we had to add additional requirements to the basic requirements we started with, then we would probably see as we go through those different iterations, how this approach actually gives us more flexibility instead of getting into maybe more compact code, but that's getting more and more difficult to understand. So there's always a trade-off, and that's something where you have to apply your judgment. But again, leveraging an approach where you look for the objects in the domain, you leverage that in your codes, and of course, you make sure that as you develop the code in each object, you focus on who does what. So I've got things to do, responsibilities to take care of, who which class should be in charge of that code. And then as I write the code in each class, I always ask myself, how can I break it down in such a way that I can in a way almost tell a story and be as clear as possible about my intent. And so I think that's pretty much it. We have a little method here to return, who's the winner. That's basically the end of that's the end of the method here, where we basically ask player one if he's the winner, and we return the data of that the winner. So again, it's encapsulated. I make sure that I have a method that does the work. So I've got a specific place to go. Of course, I could have done it right here, but it's probably cleaner. Again, it's encapsulated. I think that's definitely the keyword. And another thing is, why not have this method return the winner. So I have two players playing against each other. Obviously, one of them is going to be the winner. So why not just return that data or information? So I've seen both. There's one school of thought that says, well, a method should really do one thing and that's it. So if I do work, like in playing against, then I'm not returning data. So it's there's the two approaches. I'm illustrating the one that says a method does one thing and that's it. So that's one option. You can always debate that. I would look at it on a case-by-case basis. Okay, so I think that's pretty much it for this little piece of code. What I would like to do is take a look at the tournament part in a second session, and as we can see here, it's implemented as per the requirements as a recursive method. So what I would like to do is revisit that and show another approach that's also based on leveraging objects and classes, and in that case, getting maybe more into polymorphism, and taking a look at what an object-oriented approach can bring to the table from that perspective. But that's a different story. So I hope you found this interesting, and obviously, if you have comments or questions, please let me know. Thanks for your time. Thanks for watching. Bye bye.